All right, part 2 of the chapter 7 test review. Starting off, do you agree number 10 is very similar to the diagram in number 9?
Yeah.
It's pretty much the exact same thing, okay? So we have parallel lines here, so that helps. If I start with x, what can I relate x to?
Negative, x minus 6.
X minus 6, or I heard 5, okay? Either one works. If I do x over x minus 6, what does the other side have to be? 5 over 3. So if I cross multiply, we get 3x. What do I have to do on this one? I have to end up distributing here. We always get the 5x, but sometimes we forget to distribute to this one also. That turns into negative 30. So now solve. Subtract 5x.
2x.
Negative 2x equals negative 30. Last step here.
X equals 15.
Divide by negative 2, x equals 15. All right, number 11, we have a different diagram here. What I want you to understand about this diagram is we have angle bisector this time. What that does is that allows us to compare this triangle with this triangle. So the two triangles that the angle bisector creates, those are the two that we're comparing. Okay, so if I start with x here, what can I relate x to? What did you say? 15. Okay, if I do x over 15, do you agree I need to know what this is?
Yeah.
Okay, how can I figure that out? 21 minus 9, which is 12. So if I did x over 15, what does the other side have to be? I did x over 15, so it has to be 12 over 9. If I related x over 12, what would the other side have to be? 15 over 9. Yep. If I cross multiplied both of these, I would get 9x equals 180. Last step. Divide by 9, x equals 20. All right, number 12, we have a new diagram again, but what's nice about this one again is we have our parallel lines here. So if I start with x, what can I relate x to?
16.
16, okay. If I do x over 16, what do I have to do on the other side?
9.
Right, I agree I'm going to do 9, but why can I not relate 9 and 10?
Because it's not inside.
Right, I describe it, they're not in the same level, so they don't relate to each other. Okay, so do you agree for 9, I have to figure out what this is?
Yeah.
Okay, so 16 minus 10, 6. So this would turn into 9 over 6. Okay. If I cross multiply that here, I get 6x equals 144. Divide by 6, x equals 24. Number 13 and 14. They are the same direction, same type of problem, just different diagrams. Okay, so write some notes off to the side real quick for reminders. Okay, what it's looking for, yes, it wants to know if they are similar, so saying yes or no, but it also wants to know how we know. So there's 3 different ways we can determine how we know. One of them is angle-angle similarity. What are the other 2? Side similarity, and I heard the other one, side-angle side similarity. Okay, so when it says state how you know, I need to see one of these 3. Okay, and again, can a choice also be no? Yes, a choice can also be no, so keep that in mind as well. Okay, so on these, always start with things that you can assume. What is something I can assume in this diagram? What'd you say? The shared angle, right? Remember, whatever they're connected by, you can assume is the same. So that shared angle. And now I heard we need to check all of the other information that they give us here. So what do we do to check sides? We do ratios, right? So I heard 8 over 24. How do you know 8 relates to 24? Okay, they're the smallest side of each triangle. Okay, that's a good way to put it. What can I divide both of these by?
3.
Yep, if I go higher, I get 8. So I get 1 over 3. Yeah. And then if I do 8 over 24, what do I have to compare for the other one? 9 over 27. What can I divide both these by?
9.
Go higher to get 9, and I would have 1 over 3. So this tells us that their side ratios are the same. So, do you agree we've checked all the information we need to? Okay, so now, if we can, we match it up with one of these. Are they similar?
Yes.
Yes, because side angle side. Yep. We have our side ratios that match, and we have the angle in between. Okay, so side angle side similarity is our reasoning. And then the last thing you need to do is fill out this statement here. So, what relates to T? T, what relates to U? M, and then relates to V is L. So 2 things I need on this one. I need to see your reasoning and the similarity statement. Okay, again, can your answer be no? Yes. If your answer is no, do you need to fill this out?
No.
No. Okay. Number 14, same idea. Always start with something you can assume. What can you assume? The angle A is the same. Did it give us any other information to check? As in, did it give us any sides to check? Nope. So we check one of the 3. We have angle, angle, side, 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 side. Which one fits, if any? Angle, angle. Again, why can we choose angle, angle to determine if triangles are similar?
Because if they have 2.
Right. If you know 2, don't you agree that those 3 or those 2 also have to be the same? Okay. So angle, angle similarity is the reasoning, and then filling out our statement here, what relates to A? A, B, Q, C, R. So again, how many things do I need to see on 13 and 14?
2.
Similarity and the statement. However, if you put no, all I need to see is no. Okay? So if I know it was side, 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 it wouldn't, more than likely, your triangles would be split up. And then it would give you numbers on all 3 sides, and then you would compare their ratios. Kind of like how we did on number 1 to determine if they were similar. Same thing there. Yep. Number 15. It wants to know the value of y. What I want you to understand about this diagram is it kind of put 2 different properties together. Okay, we have our parallel lines here, and we have our angle bisector. Okay, so keep that in mind. We have both properties going on. If I start with y, what can I relate y to?
12.
I could do 12. If I do y over 12, what do I have to do on the other side?
24 over 30.
Careful.
Oh, wait.
It would have to be 30 over 24. Yep. So if I cross multiply, I get 24y equals 360 divided by 24. We get y equals 15. If you find something, what should you do? Put it in the picture. Okay. So, on number 16, it wants us to find the value of x. So, if I start with x, what can I relate x to?
27.
Where'd you get that from?
Add the side.
Yep, because again, we have that angle bisector, so we're comparing these 2 triangles here. So, what's going to help is if I know this whole side length right here. So, 12 plus 15, 27. So, we can relate x over 27. What does the other side have to be? X plus 10 over, and again, we want to add these 2 together to get 54. If I cross multiply here, we get 54x. What do I have to make sure to do here? Distribute, so we get 27x plus 270. And now subtract 27x. So we get 27x equals 270. Divide by 27, we get x equals 10. Okay. And then number 7, it wants to find the length of EG. First of all, is EG an angle or a side?
Side.
It's a side. So if I'm looking for this whole side length right here, what do I need to do to figure that out? I need to plug in x. So what's this side length right here? 10. This side length? 10 plus 10 is 20. So the whole thing is 30. So EG is 30.